Thank you all for joining the today's session. This is a wonderful day. Today we're going to cover MLOps using MLflow. Myself, Nagaraj Sengodan. I'm a senior manager in data and analytics practice in HCL Technologies.
Thank you all for joining this session on MLOps using MLflow. This is Nitin Raj, and I'm a technical consultant in data and AI practice in Cognizant.
Today we're going to talk about the MLflow and how it's going to help us to build ML apps for any organization. So before get started, let me give a little brief about myself. I'm a senior manager and I'm a certified solution architect. And I did a couple of advanced analytics projects. So that's where we implemented ML apps. So that's a story I'm going to cover in this presentation.
Yeah. So let me give a brief introduction about myself. So I'm a technical consultant focusing on the advanced data analytics and data engineering and cloud scale analytics. So I'm a certified Microsoft certified solution expert in business intelligence and data analytics.
Yeah. So without further delay, let's move on. What we're going to cover. So today we're going to talk about the ML apps and what are the stages and challenges. Then ML flow followed by demo. So we like to know what is ML apps. So typically, if you see any industry, right, if you not manage ML apps properly, definitely it will big problem for the business. So you could see any industry, right? So it's not like a software development life cycle, whereas one application, once you develop a piece of code, then it's going to run forever. Whereas ML is not the case. We have to keep train, keep monitor, and keep evaluate our model, make sure that it fit for our business. So that's where we want to see what are the typical challenges faced in enterprise world. One is a reproducibility of the ML model. Most of the cases, what happened, business of there are good data scientists build a model, deployed, and it works pretty much fine in production environment. After a certain time, what will happen? They found that the model going lesser accuracy. Then they realize they want to update the model, but they can't able to reproduce where the code is, what code they use to generate the model. And you could see Bob new, Bob latest, Bob one. Maybe the Bob might stuck with the COVID-19 and someone want to pick up the model, and you could see the lot of folders, right? So that's where the challenge is. Number two, ML operations. Day to day, how are you going to manage ML? There are quite a lot of people do the development of the model, and they're releasing it periodically. And how ML engineer make sure that the model is valid and it get the better accuracy than the previous one, and it passes all the ethical and the compliance before going into production. So that's an important step. And the model management, once you deploy into the production, we need to monitor the model, how the model is performing. So the health of the model is a key for business value. Last is the tools and technologies. As you know, it's a wide variety of tools and technologies. From data engineer, it's a different tool stack. Data scientists, they use their own stack, and the ML engineer, they use their own stack like a Docker, containers. So it's a variety of technologies. So managing different technologies is always a challenging. So these are the challenges. How MLOps going to address these challenges? So MLOps is nothing but it's a mix of the three main stack. One is a software engineer, DevOps, and ML engineer. So the good thing is people might think about when we have DevOps, why MLOps, right? So DevOps is probably I'll cover that little down the slide. So now I'll just give you a brief. Software engineer, where how we're going to write the code. DevOps is where how we're going to deploy our code. ML engineer, where how we're going to build our model. So these are the three components has to be built, which is called ML apps, which help how we can improvise our model. So if you could see, right, we have the source system and we need to prepare the data. So prepare the data means we need to make sure the data being valid. So some of the values are numerical. Let's say the quantity order, or maybe something like employee numbers. So there are some numbers will be there. There are some categories will be there. So we need to make sure that all are aligned, all are normalized before start our ML model. Otherwise, the prediction definitely impact on our accuracy, right? So we have to make sure that the data, is there any gap in the data? So is there any null values, blanks? So everything we have to make sure all will be properly addressed before start building a model. So that's a key part for data engineer to do all the transformation, make sure data ready for building a model. Number two, data scientists. So when they have the data, they have to start identify the features and train the model with a different parameter, and then they need to evaluate which model perform better. Then they release to production. um, when come to release cycle, that's where the ML engineer come into picture. So they have to validate the model with all the aspect, whether it follows the compliance, ethical, responsible, and it gives a better accuracy, which is valuable for the business. So only then it has to deploy into the production, make sure that the model works as expected. So there could be a reason that the model being developed with different versions, the environment may not be in the compared to the version they developed. The Python is a different version, maybe someone used 2.7, someone used 3, Nambi, Aconda, the TensorFlow. So there are many technology stacks, right? So you have to make sure that all the right versions are there before pushing the model to the production. So that's where the ML engineer come into picture. So if you see the whole thing, right, it's all about the collaboration between these people. So that's what the MLOps come into picture. So we'll talk about the MLOps lifecycle. So this is where we identify that how business value will be gained whenever the machine learning model is being built. So it could be anything. So it could be neural net, it could be a simple machine learning model like a linear regression, or maybe any model, right? When you developers build and it's pushing to production and it has to yield the business value. So that's when the real benefit for building the models, right? So how are you going to maintain the business value from your model? So that's where the MLOps come into picture. So any model goes, it has to follow the continuous integration, continuous deployment life cycle. And the orchestration, the orchestration, ML orchestration, means once you push into production, so you have to make sure that the model works fine, the health is good, like its response correct. So we have to make sure that the production model run with the proper configuration so that it capable to serve all the business needs. So let's say if you deploy into the small container and there's a downstream applications, there are more than 25,000 people are consuming it, definitely going to it won't respond in time. So definitely it impact the business, right? So there are many aspects. And come to the model governance and business impact, we have to make sure that model ethically it follows all the standards, whether it's compliance, all the security standard, because the data is a very key. So we have to make sure everything in align to the standard and compliance. And the model governance, so these are the key aspect will help us to uh, increase our business value. um, Let me bring up a one interesting story. If you could, I think most of us heard about the Gentrify. That's one of the startup company. They what they does is they take the name and they predict what gender they are belongs to. That's a service API they exposed. That's a new startup company. Soon after they launches, they started getting a comments from the people saying that it's a gender biased. If you type like a doctor, then it's predicting more towards to male. Then it's a big challenge. So um, because of that, they end up shutting down the company within a month's time. So that's how it right now in the market. So whenever you build a model, make sure that it should be aligned, it should generate a business value rather not creating an issue in the market. Yeah. um, so that's the importance bring from ML apps. um, Yeah, so let's talk about the differences between the software lifecycle and for the ML lifecycle, and then we'll jump into the how MLflow help us. If you see software side, we have the typical lifecycle like a coding, and then unit test. We have a peer review, and then approval, commit, test release, and production release. Um, Same thing. If you check for the ML side, you have the similar cycle. So these are the standard steps. However, it could vary case to case, even for the software as well. But mostly, this is how the steps been involved. So for the ML side, the very first thing is analyzing the data preparation, building a model, evaluate the model, then optimize it. Once you optimize the model, then you deploy, and then you monitor, retrain continuously. So that's why you start getting benefit, right? So let me compare these two stage by stage. So the goal for the software is to meet the functional requirement, whereas for the ML, they have to get the better accuracy by optimizing the metrics. So that's a goal for these two. And if you see the quality, so quality is depends on the code for the software lifecycle, whereas quality is depends completely on the data, choice of algorithm, parameter we using for our application. So that's where uh, yeah. So quality completely depends on the data, choice of algorithm, parameter, and technology stack mostly single stack, whereas ML it's a combination of multiple stack because data engineer, data scientist, and the ML engineer uses a different stack. And the final one, the outcome, softwares are pretty much deterministic. We know what code written, that's how that's going to function. Whereas ML, it's completely based on the data, it's going to work. Um, so these are the challenges and how difference between the software engineer and ML engineer. So now let's see how MLflow help us to solve this gap. I'll pass on this to Nitin, my colleague.
Okay, thank you, Naga. So let us see in detail about the MLflow. MLflow is an open source platform for the machine learning lifecycle. MLflow is built on open interface philosophy, defining several key abstractions that allow existing infrastructure and machine learning algorithm to be integrated with the system easily, meaning that if you are a data scientist who wants to leverage MLflow and you are using particular framework that's currently unsupported, the open interface design makes it extremely easy to integrate that framework and start working with the platform. I'm going to walk through each of the MLflow four components, that is tracking, projects, models, and registry. Tracking is a centralized repository for metadata about training session with an organization. Projects is a reproducible self-contained packaging format from model training code and showing about the training code run the same way regardless of the execution environment. Models is a general purpose model format enabling any model produced with MLflow to be deployed to a variety of production environment. Registry helps to solve three critical problems in the production machine learning application. It prevents from deploying the bad models by introducing the model administration and review. It integrates with MLflow tracking to provide the complete picture of every model within your organization, including the source code, parameters, and metrics. It allows it also provides centralized activity logs, recordings, entire collaborative process from model development to deployment, complete model description and comments. In the MLflow workflow, we can see that the data lineage through the MLflow model lifecycle is as follows. It starts from the training the dataset, say your ETL from the from your raw data. You may have the different versions of the training data and the relevant parameters and metrics, as well as the model file can be logged in the training API. In the MLflow tracking component, to run the detailed page, you can register a new model or create a new version of an existing model. Finally, you can maintain the different versions of the model in the lifecycle stage in an MLflow model registry component. The MLflow tracking server. There are several concepts associated with the centralized training metadata tracking repository that MLflow has enabled. The first thing is hyperparameter or the configuration knobs that impact the model performance. These can all this can all be saved using the MLflow APIs and a centralized tracking service. Additionally, users can log the performance metrics that provides the insights into the effectiveness of their machine learning models. Additionally, for reproducibility, MLflow enables user to log particular source code that was used to produce a model, as well as its version by integrating tightly with the with to get the map every model to a particular commit had further, and perhaps most importantly, data and models. So MLflow projects is a self-contained tracking code projects specification that bundles all of the machine learning training code along with its versioned library dependencies, its configurations, and its training and the test data by fully specifying the complete set of dependencies for a machine learning training task. MLflow enforces the reproducibility across the execution environments, and it does this by installing all those libraries and achieving the exact same system state wherever the code is running. So what does an MLflow project look like? At its core, MLflow project is simply a directory. It's a directory with this optional configuration optional configuration file, and it contains the training code, the library dependency specification, and the other data required by the training session. These library dependencies are specified in multiple ways. For example, users can include a YAML formatted Anaconda environment specification to enumerate their training code's library dependencies. They can also include a Docker container and the MLflow, and the MLflow will execute that training code within the specified container. Finally, MLflow provides a CLI for executing these projects as well as the API in a Python, R, and Java. And these projects can be executed both on the user's local machine as well as several remote environments, including the Databricks job scheduler as well as the Kubernetes. Similar to a project, a MLflow model is also a directory structure, and it contains a configuration file, and instead of containing the training code, this time it contains a serialized model artifact. It also contains a project, the set of dependencies for reproducibility. This time we are talking about the evaluation dependencies in the form of a Conda environment. Additionally, MLflow provides model creation utilities for serializing the models from a variety of popular frameworks in the MLflow formats. Finally, the MLflow introduces the deployment APIs for productionizing and deploying any ML model to a variety of services, and these APIs are available in the Python, Java, R, and by the CLI format. You can now, in the MLflow registry, you can now see the tags on your model versions and the registered models. The comparison view is also enhanced for the model versions, enabling you to compare the schema across two perspective versions, or more, making the decisions about which model to move into the staging or production. And finally, the model archiving experience is simplified. You can now opt to archive all the existing production versions of a model when you transition a new version into the production. This simplifies and de-risks the upgrade process.
In this demo, we'll see how MLflow help us to implement the ML apps. We are using ElasticNet, which is a regression model, and then MLflow tracking service, followed by MLflow model registry. It's a quite interesting one. Let me get into the piece of code. Before that, 2 point I like to highlight. One is we are using Azure Databricks. It doesn't necessary that we have to use Azure or AWS Databricks, because MLflow is an open source product developed by the Databricks, so you can use it on-prem environment as well. However, the benefit of using Azure or AWS Databricks is you could see the tracking server available right on this same screen, and MLflow also being available in the package. So all you need to do is just import your MLflow and start using it. If it on-prem, you have to install the MLflow library, and then you can start using it. So that's the differences. So let me take the model one. So we are using wine quality, which is an open source dataset downloaded from the web, and I added into the Databricks DBBus file system, which assigned to the wine data path variable. So the next cell will talk about the two function. One is evaluation of metrics, root mean square and R square values. And the next function is the train model, where we are going to read the CSV file, and then so this is the piece where we read the CSV file, and we do the train and the test data, and we create our elastic net model and passing the parameter alpha and the lone ratios, and then we passing the data set to train and test how it printing the values. You can see we have the MLflow and it logged the parameter metric. Um, so the quick update is MLflow has a new version which support auto log. Means we need not to log each parameter metric line by line. All you need to do is you just call MLflow dot sklearn dot auto log. So that will take care of everything. So it's not only available for scikit-learn, it also supported most of the major libraries like TensorFlow, Keras, PyTorch, and so on. So if you come to here, you could see the variables. So let's say instead of point 0.5, so I can make it 0.60, and then yield ratio is a 0.7, and then I try to run this model and see how the root mean square and the R square values are getting into. I think seems to be fine compared to the earlier run. However, I want to see how the earlier runs has been performed. So the best way to do it is the experiment. So this is the model tracking come into picture. So I just click on here. I can see the each run how it's been performed. So it's a quick snapshot to see a different run and how it perform. If you want to detail one, just click on the link. It will take the tracking server and see the complete list of run. So the good part is the UI has a most commonly used features like a filter, your record set. So you can just put that like a my root mean square is greater than zero point 0.8. I don't want to see the lesser than zero point 0.8 so that I can see only those run which are getting the zero point 0.8, and then I can compare this one and choose which is the best one to productionizing it. And also I can download the CSV. I can compare options. So most importantly, it has a reproducibility, so you can see what code associated to the each run. So it captures the code and also reproducible run. So you can reproduce a run and you can see all the metrics how it's been generated. Finally, the artifact, which says about the model definition, conda, the environment details, and the model pickle files. Even if you want to attach artifact, anything like a chart, graph, whatnot, yes, you can do that with it. So this is the tracking server capability, MLflow. So help us, anyone can tracks back the model and check the code used to generate the model and the run experiment, everything they can reproducing it. So once I finalize this is the model I want to productionize it. So how I make it to productionizing it. So that's where the model registry come into picture. I'll pass on to my colleague Nitin. Over to you.
Thank you, Naga. So now we are going to see one of the important feature in the MLflow, which is nothing but a model registry. During productionizing, we use the feature called model register, which helps to enable the workflow for doing the deployment. It's the integration between the data scientist and the ML engineer. As a data scientist, I say this is the final model and I want to register this model with the model registry. So this is the piece of code that we can see over here, which is going to which will help us to register this model into the model registry. So I'm going to execute this piece of code. We can see that the model has been registered. As soon as the model has got registered, we can go into the models tab in the left hand side, and we can see that MLOps demo wine model with the version 16 has got registered into the model registry. So I can say that this version 16 is the better than the any earlier versions that are available. And I can say the ML engineer, can you consider the version for deployment? So I'm just opening this line of item. So we can see that for this particular model, we can see the history of versions over here. And if you go to the second page, we can see that version 16 is available over here. So as a data scientist, I'm going into the version 16, and we can see that we have this stage over here. So as this user is an admin user, we can see both the option of requesting to the ML engineer to move this from this version from run stage to the staging or production, or we can straight away push this version of the model to either to the staging or the production. So in the real world scenario, what a data scientist will do is nothing but they will the data scientist will request to move from run to staging. Let me do that one. So as a data scientist, I have to give the command. So as soon as a data scientist make a request, we can see the activity performed by the data scientist over here in the activities area. And as soon as the step has been completed by the data scientist, the ML engineer will get an option to approve or reject this particular staging move. So Before an ML engineer going to approve or reject this model, what ML engineer will do is nothing but he will go into the run ID by clicking over here. As Naga has already explained, so we can see within this run ID of this particular version of the model, we can see the in-depth view of the particular model. We can see all the information of a given model of this version. So we have the pickle file, we have the YAML file, and we have the model, and we have the parameters being maintained here. So, and in this page, the ML engineer can review the parameter passed for this particular model and what are the metrics outcome as well. So once the ML engineer is happy about it, the ML engineer will go back and will approve this particular request by giving a comment. So as soon as the ML engineer approves this request, we can see that it is being captured in the activity area. So let's go back to the registered models. So we can see that the latest model version is being moved from none to the staging area. So the downstream applications need not to know the run ID or the version ID, etc. All they need to know is nothing but they need to capture the model name, let's say MLOps demo wine model, and then whether the staging or product, whether the downstream application has to access the staging or production. Whatever the version is being moved, the lineage will be taken care internally. In this way, it is easy even though there are multiple downstream applications start using this particular model either in the staging or in production. This way, the concept of CI/CD is taken care, and we can reproduce the code, which code base is used to generate the model. Also, you can trace back your run IDs, your run, and see the metrics being generated out of it. So this is the benefit of using the model registry. And let's go back to the workspace, to our notebook. So now it's a part of consuming the model. So this is the piece of code that helps us to consume the model that has been registered in the model registry, either in the staging or in production. How we are going to do is nothing but we have to give the model name here, and then we have to give whether we are going to access staging or production. So let's say I have given the staging as I want to access this staging. So in the downstream application, they need not to worry about changing the code. They just need to run their code. So if we run the code as we are pointing towards the staging, we can see that the latest version, that is nothing but version 16, that is being moved to staging, is accessible now. So that's it from the demo side. Now let's go back to the presentation.
What next? So if you want to get your hands dirty with MLflow, just pip install MLflow or get into Azure or AWS Databricks. It's all ready to dive in. Want to know more about MLflow? Yeah, you can check in the product page, mlflow.org. You can see a lot of materials available, docs and materials. Regarding this demo code and the presentation, everything available in our GitHub repository. Yeah, feel free to connect us, LinkedIn, mention in the below slide. Anytime, yeah, you can ping us. We can have a chat with the coffee virtually if the situation is not that so great. Once you're back, yeah, we can have a face-to-face connect. Thank you all for joining the today's session. Hope you all enjoyed. It would be great if you spare a moment and give us a feedback. I think you have the link for giving the feedback. So probably if you could valuable feedback that help us to improve in our next session in upcoming data summit next year. Thank you all. Have a nice day ahead.